member under the patient's leg and any remaining bellplane member to collapse, forming rubble in the bottom of the cavern. At this point, the solvent is switched to a brine that is fully saturated in salt and partially saturated in potash. This solvent will only dissolve potash or potassium chloride and not salt or sodium chloride, which reduces the amount of salt that will be stored above ground. This process is known as secondary mining. Once secondary mining is complete, the cavern is left full of brine to help minimize subsidence. Directional drilling techniques are used on the production wells to allow for multiple wells to be drilled from the same pad, which minimizes surface disturbance. Up to 40 wells will be drilled from each well pad. An 80-meter pillar is left between each of the mining caverns. This results in a relatively low extraction ratio. 54% of the potash beds remain. The pillars are sized to ensure cavern stability and to minimize subsidence. Subsidence is the localized lowering of the land surface as a result of developing underground caverns. Using solution mining techniques to extract a potash deposit will result in substantially less subsidence than if underground conventional mining methods are used. Using an industry-accepted modeling method, the proposed cavern layout is predicted to result in an ultimate subsidence of 6.7 meters. The subsidence will occur gradually over a large area and will occur gradually over time, taking up to 100 years to reach the ultimate subsidence. On the local scale, the ultimate subsidence is predicted to result in a change of 0.2 inches across 3.3 feet. Therefore, the maximum slope of the subsidence is expected to be 0.22 degrees. This will not be observable to the naked eye. The wellfield is connected to the plant site via a series of 6 pipelines ranging from 20 inches to 30 inches in diameter. The pipelines will be buried 8 feet below the ground surface. The brine is processed using evaporation and crystallization. During the evaporation process, water is evaporated off, collected, and returned to the primary mining caverns. Recycling the hot water results in lower natural gas consumption and a 30% reduction in water consumption. During operation, the process will be optimized to limit the amount of water required. Dust from the process is recovered